tonight. We really appreciate that. Okay, got it. Let me share my screen. Been a while since I've done this. Oh, now I can share PowerPoint. Okay, can everybody see my PowerPoint?
Yes.
Yes.
Yes, okay, good. So thank you. I can't see anybody, that's not good. I want to see smiling, happy faces. How do I do that?
On right-hand side, I guess.
Here we go, now I can see it at the top. Okay, I'm looking at smiling, happy people, so that's a good start. It makes it so much easier to give a presentation. Okay, hi, I am going to talk about DynamoDB. I'm assuming that most of you or all of you have used SQL databases and you're familiar with the relational model of database. So this presentation, I'm really going to focus on DynamoDB and how it's different and how you have to think differently about how you store your data and how you access your data in order to take advantage of DynamoDB scalability. So that's the sort of the high level overview. So I'll start with the DynamoDB philosophy of what's it about and why would you use it? I want to cover a lot of important concepts, in particular how the data is stored inside the database, and that will really help you understand how to write efficient queries. I'll go through some of the basic operations like GetItem, PutItem, scan, and query. These are very, well, don't use scan very much, but the other three are very, very common operations that you use in DynamoDB. I'll talk about secondary indexes, which is a way of storing data for more efficient access. I'll give some code examples in Typescript, but it could be any language you want. I mean, Java, Golang, whatever you want, they're all pretty much the same as far as DynamoDB is concerned. And I'll talk about some of the things that you'll miss, right? So DynamoDB doesn't support joins and it doesn't support aggregation. So sum and count and average and things like that, it doesn't support. So you say, oh my gosh, how could I possibly use this database if I don't have a join? Well, we'll talk about actually how you do it. And finally, I'll talk about transactions. DynamoDB does have transactions, but they're not quite what you expect. So firstly, I want to thank Galvanize. I wrote these slides when I was actually an employee of Galvanize a few months ago, and I'm no longer an employee of Galvanize, but they were nice enough to let me use these slides for a public presentation. So thank you very much, Galvanize. Great place to work. I worked there for 6.5, 7 years almost. Really great place. I encourage you to check it out if you're interested. Okay, let's start with the philosophy. DynamoDB, what's it all about? Well, as Yuri mentioned, it's a NoSQL database using key value pair access. So very familiar model for anybody who used Redis, Cassandra, or anything like that. Basically, you have a key and then you say, get the value associated with the key or put the value associated with the key. It's a little bit more complicated than that. You can actually get multiple values back. You can do a query based on a range of values, and we'll see how to do that. But generally, you've got to forget about SQL. Don't think about all the wonderful things you can do with SQL because those are not efficient. Those are not scalable things. So Dynamo is known for being extremely scalable. In fact, it originated, I believe, from Amazon shopping carts, probably about 15 years ago. There's actually a research paper you can read showing all about how it works internally. But the idea is if you think about going to Amazon.com, you know how quickly it loads that page. It's personalized for you. It says, is this person a Prime member? What are the recommendations for books? That comes up in like less than half a second. It's amazing how fast it is. Part of the success is using DynamoDB. Even though there are millions and millions of users around the world using Amazon at any one point in time, it's still lightning fast. And that's because of Dynamo. One of the reasons, I'm sure. So one of the things that AWS will really talk about in their marketing material is single digit millisecond access. And that is true for certain accesses. If I'm trying to get a single key value pair from DynamoDB, get it or put it, it's a single digit millisecond, less than 10 milliseconds to do that. And you might say, well, hey, you know, my local Postgres server or my local MySQL can do that. No problem. I can query a database in 1 millisecond. What's the big deal? Well, again, have petabytes of data and millions of users on your Postgres system and see if it's still a single digit millisecond. Probably not, right? Usually when you get to like 10 concurrent users, suddenly things start slowing down. So DynamoDB is designed in such a way to maintain that great performance, even though you have a lot of users and a lot of data going through the system. It's serverless. Serverless is a wonderful buzzword. What does it actually mean? What it means is you don't have to start a server. Now, there are servers there, obviously, in the background. They are there. Amazon manages them for you, but you don't have to think about it. You just go in, you create a table, you store stuff in the table gets big, You don't have to do any maintenance. You don't have to think about it. You can delete the table and you stop getting charged for it. There is no server. You don't have to worry about upgrades, booting, rebooting, all of those annoying things that you have if you're using, say, RDS, Postgres, or MySQL, or one of those services. You're constantly worrying about when's my maintenance window and when do I need to shut it down to upgrade it, and so on. Okay, and as I mentioned earlier on the previous slide, it is a very different way of thinking about data access, right? Don't think about SQL anymore, because SQL is based on relational calculus, which is extremely mathematically flexible, and you can do absolutely anything in it. You cannot do that in DynamoDB. No joins, no aggregations, and transactions are more strict. So I want to start with an example. I'm going to use this table of data consistently throughout the whole presentation. So this looks very familiar. There's nothing surprising about this. The left-hand field is the organization ID. In our case, we just have organization 1, 2, and 3. And these are just different customers. Like at Galvanize, there are different customers. Each customer has different users, or a customer as an organization has multiple users. So we say, what is the organization ID number and what is the email address of the user within that organization? And then we have their personal name and the family name and the birth date and then what department they're in. So this is exactly what you would normally think of as a SQL table, right? There's nothing different about it. Now, what's interesting is if you look at the top left here, there's a partition key, which is the org ID, and there's a sort key, which is email address. Now, that's what's kind of unique. So let's look at this. Partition key, or otherwise known as the hash key, is actually how DynamoDB allows you to figure out what server the data is stored on. And we'll show an example in a second. The sort key, otherwise known as the range key, is the order in which the data is stored so that you can very quickly look it up using something like a binary search. So let's now switch. Now you've memorized this data table. Let's switch to actually how it's stored. So I'm sorry for the writing is a little bit smaller on the screen, but what you see now is that I have 3 partitions. The first partition is essentially everything that has organization ID equal 1. Second one, organization 2, and organization 3. Now, I'm simplifying it a little bit. In reality, it's not quite this easy, right? It's not just, this is not required to be a number. It can be a string, it can be anything, basically. What DynamoDB do will hash that, run it through a hash function, come up with a number. That number is used to identify what partition the data is on, and then it maps that to what server it's running on. But the key point here is that the data is partitioned into multiple partitions. Each partition is kind of a unit that you can operate within. Now, if I look at the second one, the sort key, notice that these email addresses are now in order. So Brianna, Jamal, Joe, Nick, that's alphabetical order. Adam, Chung, Ingrid, Patsy, they're all in alphabetical order within the partition, okay? So this is now naturally leading to a very efficient way of accessing data. So what you see here is if I'm trying to look up data, now your pretty pictures are hiding my screen. Okay, this is the get, I'm gonna put it down the bottom for a second. This is the get item operation. So if I'm doing a get item, what I do is I say, I have a partition key, which if you remember was the organization ID, and I have a sort key, which is their email address. If I want to get an item, I have to take both those keys together to be what's called a primary key, essentially, and I'm going to look it up. So I'm going to take a hash of the partition key, which tells me what partition number it's on. In this case, maps to partition 3. DynamoDB knows that partition 3 sits on server 1. Just happens to know that internally. You don't have to think about that at all. It just does that. And when you get to partition 3, then it has all the data of that partition sorted in sort key order. Okay, if you remember our original data, if I go back again, partition key was the org ID, sort key was the email address. So taking the org ID, figuring out what partition, and within the within the partition, everything's sorted by email address, and I can very quickly do a binary search on this data in order to find out where everything is and get the data I want. Now, that's super, super efficient. If you keep in mind that there could be hundreds of servers on a really, really big table, there could be thousands or millions of partitions. It's very, very quick to do an order one complexity operation to find the partition, then do a binary search within that partition to find the data item I'm looking for. And this comes back to the statement I made earlier about being single digit millisecond. even with thousands or millions of users using it, it's extremely fast to do this operation. Now I want to stop there. Are there any questions about that basic workflow before I move on?
May I ask one question?
Sure.
Also, usually for NoSQL database like DynamoDB, it's kind of like a common practice to scale horizontally database, like having server 1, 2, 3, and like separate data for each partition. Like let's say server 1 has partition 1, 2, 3, and the server 2 have kind of like partition 4, 2, 6, and
yeah. Now, in this case, I don't know how it works. I mean, I just trust that DynamoDB is going to do the right thing. So it will manage the mapping of partitions to servers, but that's not in the documentation anywhere. I don't actually know how it works. It's all magic that Amazon handles for you.
Cool.
Yeah.
Hey, Peter, another question. So while fetching like might be very fast, I guess like writing in sorted order can be a bit slow, right?
Writing in sorted order. So if I'm doing a put item into a partition, yeah. So, I mean, you don't really think about doing multiple things at a time. Like usually just one get and one put is the general workflow that you have. If you're inserting a whole bunch of things, yeah, it's not necessarily going to be the most efficient because it has to do this lookup every time. It has to figure out the partition. It has to write it every time. So you're right. It's not the most efficient to be doing bulk inserts.
Okay. Yeah.
Okay. Great questions. Now let's move on. This next one is what's called a scan operation. Now, a scan operation is something you shouldn't actually do. I'm just showing you to show you actually what it does. Now, if you think about a SQL database, you typically do things like select star from table. Well, we've all done select star from table, and it's fine as long as there's only a few data items. But if there's a bazillion data items, you kind of start regretting it, right? That you shouldn't have done that. You can do exactly the same thing with DynamoDB. You can say, basically scan all partitions and all rows. Don't do this. Don't do this in a production system unless you actually mean to do that, right? And for example, you might be doing some sort of data migration where you have to visit every record, look at it, update it, go to the next one, look at it, update it, and so on. That's more of a maintenance task. During normal inserts, normal queries, you would never use a scan operation because it's not optimized. It has to go to every partition on every server one by one and so on until it actually gets through all of them. Now, I believe you can do it in parallel as well, but this is really not an efficient operation at all. You shouldn't plan on doing this. What you should plan on doing is what's called a query, right? So in a query operation, you basically give it again, a combination of the partition key to say what partition you want to access. And, pictures are on the side now, that's cool. Okay, so you want to figure out what partition you're going to look at, but then you actually want to return a range of values. Whereas first, when I showed you GetItem was only going to give you one value. So it would do a binary search on this and return the one item that you're looking for. A query operation, however, says, hey, start at a certain key value and finish at a certain key value and give me everything in between. Okay, and this is quite useful, right? You might want to say, hey, in a particular organization, give me everybody whose birthday is between October and November. And the query operation will, do a binary search to find the starting point, and then it will just sequentially go through everything until you hit the end point, and then it will stop and return all of that data. So query operation is not as efficient as GetItem, but it is still a very efficient way of looking up data. And the key reason is, of course, that you start out by looking at one partition. Your hash of the partition key gives you one partition. You go exactly there, and then it's very efficient to operate within that single partition. So you can do clever things. You can start to say, hey, between this key and this key, or you can say everything up until this key or everything after this key, or whatever it is you want. But it has to be a range of keys within that partition. Now, what's extra good now is that you can actually, once you've got the range of data from your query, there is the ability to go and filter that later on. And a filter expression is where you can actually do much more general expressions, like you still use less than, greater than, equal to, not equal to, but you can use not, or, and. You can start to do all the general operations that you're used to in SQL, because well, basically, it's no longer DynamoDB at this point. I mean, it's given you the raw data, and now there's some service or some library or something afterwards that filters the rows that you got, filters them down further. Okay, then you get your final data set. Okay, I'm sure this is blowing some people's minds because it blew my mind when I first learned about it. I'm like, how the heck am I supposed to use this? I mean, I get a single lookup of a partition and I get a single lookup of a key, but now I'm like, I have to pick a range and then I get to filter the range again. Yeah, and it took me a while to really understand how to use this effectively. This is not SQL, right? It's way higher performance than SQL, but it is a lot more confusing to figure out how to access the data that you want. Okay, so let me address something here. One thing you're probably thinking right now, and I certainly did as well, is that querying by partition key and sort key only feels very limiting. You're like, okay, so our partition key is our org ID and our sort key is my email address. Does that mean I can only look up using my org ID and email address? That's really limiting. I can't do anything useful with that. And that's absolutely true. So that's why we have the concept of secondary index. So a secondary index is basically the same data that you had in your original table, but stored differently, stored using different partitions, stored using different sort key, right? So there's two types of secondary index. One is called LSI, or local secondary index. That's when you use the same partitioning, but you sort the data in a different order. So you have your original base table sorted by email address, and then you have a different sorting of that same data in a different storage location based on something else. And the GSI, the global secondary indexes, which is what I tend to use a lot more often, is when both your partition key and your sort key are different. Okay, so data is replicated for performance reasons. Now, if you're a SQL database, relational database expert, you're cringing right now because you're so used to normalizing data and joining data and indexing on fields and doing all sorts of clever stuff. And I'm saying, you know what? DynamoDB, we're just going to replicate everything. You got 2 copies of the data now. You're like, that's terrible, right? But it takes a while to get used to it, but it's a very, very efficient way of operating. Once you learn this way, it's super, super important. So here's another way of looking at a data. This is the same data that we had before, but now I'm using a partition key is the department, whereas before it was my org ID, and my sort key is my birth date, whereas before it was my email address. And I've chosen just basically to replicate only the personal name and family name, not all the other information I had on the previous table. So this is exactly the same data I had before with a couple of fields thrown away. But I can now use, this is my partition key and this is my sort key, department and birth date. So I'm looking at exactly the same data, but I'm able to search it differently than I could before. So how this works is that when you do a put item operation, so when you actually add something to the database, well, you can only put item on the base table. And in my case, the base table was org ID and email address. So I can only put item on that base table. But what DynamoDB does automatically for you, it propagates any data that you write to the table to all the secondary indexes. So that very quickly, within milliseconds, you can query those secondary indexes to get that data that you updated and query it in different ways. Okay, that takes a while to get used to. So when you're working with DynamoDB, you spend a lot of time trying to figure out what your secondary indexes are. What keys do you want to use, partition key, sort key, but Dynamo handles all that for you. Once you've actually figured it out, all this replication just happens magically. Okay, I think I'll stop there for questions. Are there any questions about how indexes work? Okay. Some questions in the chat. At the cost of storage, absolutely. So storage is really cheap these days. If you are Amazon in particular, or a large company, you don't mind paying for storage, and you trade it off for performance, that's the decision you make. Is data duplication a literal copy, or is it actually just a clever bunch of pointers to the source data? That's a really great question. It can be either. You can choose which which fields you want to project, as it's called, into the index. If you want to project all of them, that's a copy of all of them. Or if you choose not to, you can still go back and access those fields, but it does require another lookup. So it has to fetch the row and then go back to the base table to get the original data. So both ways work. Like a multi-threaded search. Yes, yeah, exactly. Any questions? Any more questions about how this works? Okay. So let's look at some code. So I've shown you GetItem, I've shown you PutItem, I've shown you query, and I've shown you scan. How do these actually work? So here are some examples. This is Typescript. It looks a lot like JavaScript, and basically TypeScript is JavaScript with types. If you love TypeScript, talk to Yuri and Mike, because they've got jobs for you, I'm sure, at Galvanize. So just to show you how this works, this is a function that will add a user to the table that I showed you earlier. So I'm passing in an org ID, which has type number, an email address, which is type string, and name, which is type string. That's what I'm passing in to insert to this database. Now, if you're clever, you'll notice that I'm just saying name here, whereas on my actual table, I had personal name and family name. I just needed to compress it onto one slide. That's why you only see one name here. What you do, and this is using the standard AWS SDK for JavaScript, and TypeScript just fits in that perfectly. What you need to do is you need to create an object. The type of the object is PutItem input, and it has two keys. The first key is the table name. And this is just a JavaScript object. Table name and the name of the table in DynamoDB. Oops, didn't you do that? What am I doing? Here we go. The second one key is item, which itself is a JavaScript object, which has three keys in it. I'm inserting the organization ID, I'm inserting the email, and I'm inserting the name. These are the three fields that I'm putting into my database. And these are the values. Now, this looks a little bit funky here because, again, each one of these is a JavaScript object. So org ID maps to a JavaScript object, which, again, has a key of n. Now, n says that this is a number that you're inserting. Email address, it's an S, which means it's a string, and name is also a string. So you basically provide the whatever value you want to insert into the row in the database. Now, this is kind of weird. If you look at org ID, you actually have to convert it to a string. It's weird. I don't know why they did it this way, but org ID is a number. You convert it to a string, but then you say n, which means it's a number. It's a little bit funky. It took me a while to get used to it, but it does make sense in the end. Finally, I now want to actually insert the item into the database table. So DynamoDB is a variable that contains my AWS client. If you've ever programmed AWS API, you know exactly what I'm talking about. You create a client, then you invoke methods. The PutItem method is what I'm calling, and I just basically pass all of that stuff, that big JSON object there, and it goes and inserts it into the table. Now, it does return a promise in this case, if you know what JavaScript promises are, and then you just wait for that to finish. It's a very asynchronous way of doing things. Okay, so that's an example of adding user using the PutItem call, and that's how simple it is to insert. Any questions before I move on to the next example? No, okay. Let's move on to the next one, which is query. Query is not so easy. It gets a little bit more complicated. So my query function, I'm just going to pass in my organization ID and that's it. So I'm saying, give me the list of all users in my organization. That's it. That's all I want. So again, I'm passing in a JavaScript object. It has type query input. Now, if you're a JavaScript expert, this will look weird, right? Because TypeScript allows you to put this type specifier on it. And that's really useful because then your IDE can give you all sorts of auto-completion hints and it can tell you when you're missing some required field and so on. So that's why TypeScript is a great language. So again, I need a table name, which is the name of my DynamoDB table I'm going to insert into, query from. Then I have key condition expression. Okay, now I'm just going to jump back a few slides and show you what that is. So key condition, this one here. So key condition expression is the middle thing here, where I said, here's the range of values that I want. and here's the partition that I want. Okay, that's the key condition expression, is that part. This part on the right here is actually the filter expression. That's a whole different thing, but I'm not going to show that example. Okay, so here again, the key condition expression is org ID equals :org ID. Okay, what's happening here is that this little expression here is specifying what partition key do I want and what sort key do I want. Now, in this case, I want the entire partition, and I don't care about the sort key. I want to list all the users. I want them all returned to me. So the :org ID bit is a little bit confusing, because then you have this other thing that says expression attribute values, and that's where I define what :org ID is, and I define it to be the org ID value that I passed into my function. Okay, starting to look a little bit confusing. I'm not surprised, because it is. I'll show you in a couple of slides how to make this a lot simpler. Again, so I have this object. I'm now going to pass it in to my DynamoDB.query, pass it in, get the promise, and we'll wait for the promise. And what I get back from DynamoDB 10 milliseconds later, or whatever it might be, is a JavaScript object that has an items key in it. The items key may actually be empty, so I do the $., so it doesn't give me an error. And then I map every item that I get back through this function that I'll show you in the next slide. So again, the summary of what this is doing, it's going to the partition for the org ID, which is given by org ID variable. It's going to return all of the users in that partition, and it's going to return them in sorted order, because the sort key is the email address. Now, it may also do pagination, which is kind of fun, because you may not get all the data that you asked for at once. It may give you a little token that you can hand back again next time you do the query and say, hey, give me the next page of data, and so on. So you may have to do multiple times if you have a lot of data. Okay, now that little function that I showed you here, the map to object function, that's a little thing that I wrote. And what that does, it takes an item, which is a type attribute map, and this is kind of the return value that DynamoDB gives you, and it reaches into that item, pulls out the various fields, and then uses the .n or .s based on what type it is to actually give me the object that I want. Okay, now if you're like me, you're probably looking at this saying, whoa, that's a bit confusing. And sure enough, it is. It's a lot of extra work. Now, what I've shown you here is the fundamental base DynamoDB API. That's it. You can use this, and I use it a lot, but there are better ways of doing it, okay? In particular, recently they came up with a new syntax, a new way of doing this. It's called Particle, PartiQL. You may have seen it advertised. I think it was like 6 months ago they announced this is available. They said, hey, you know what? It's kind of confusing to have all of those JavaScript objects and all of those fields you have to fill out, and it takes a while to get it right, and even experts get it wrong all the time. So why don't we have something that looks a bit more like SQL? So they did. They did exactly that. So here's a different syntax. We use the execute statement method, where you just basically pass in something that looks like SQL. So select star from table, where org ID equals ? and email equals ? and then you pass in whatever parameters you want. And if you're a SQL programmer, which I'm assuming most of you are, this will look super easy to understand, super obvious, okay? Now you're gonna say, well, wait a minute. If you've got SQL, why do we have to learn all that stuff before? Well, you know what? This isn't full SQL. This just looks like SQL. So what it really does, it parses this SQL, which is a very compact syntax, and says, I'm going to use a GetItem or a query or a scan underneath. So it's actually just making it syntactic sugar. It makes it easy for you. Now, this particular one, it's actually going to be a GetItem call, because a GetItem is where you have to provide a partition key, which is org ID, and an email address, and that will get one item. So this actually maps to a GetItem call in DynamoDB. Now, if I did a little bit differently and said, hey, let's leave the email address off. If I said select star from table where org ID equals ? then it will say, hey, you haven't provided the sort key, so I'm actually going to do a query operation for you. So it does the previous case of going through all the return rows from that partition. Again, you don't need to worry about that. You just need to write good SQL. However, if you did this, if you did select star from table where email equals question, you haven't provided the partition key. You didn't provide org ID, so it's going to do a scan. So it's really inefficient. Okay. Now, I want to stop there and see if there are any questions, because I know I covered a ton of stuff. And actually, there are some discussions in the chat. Yes, particle looks safer. Absolutely. Okay, any issues with unparameterized reads writes to DynamoDB? Is it safe to pass that whole parameter object as exampled? What sort of issues do you think of, like SQL injection or? Yes. Yeah, I think if you're using the original syntax, there's no problem because, yeah, I haven't really thought about this. Yeah, I'm not sure about using the particle syntax, though. If you use particle syntax, there might be some issues for sure. But I think in the original syntax with the JSON object, I don't think there's any problems. But yeah, good question. Okay, any more questions about the syntax? Okay, so I recommend as a starting point, you use the particle syntax, highly recommended. But keep in mind, you really do need to understand what a get item, a query, and a scan actually is doing underneath. Because if you write the wrong query, if you try and write general SQL, you're going to end up with a really inefficient query and you're not going to see the performance that you actually want to have. So that's a really important thing to do. So definitely look at particle. There are also other libraries. Like if I go back to my previous example, this map to object function, there are actually libraries that will do all that object relational mapping for you. You don't have to write this function yourself. In basic DynamoDB, you do. But if you use one of those libraries that sits on top of DynamoDB, you will not need to do this. But it's great to understand the theory anyway. Okay, any more questions on the code? Everybody excited about writing DynamoDB client code? Whoa. Okay, maybe it's just me. Okay. So let's go and talk about some more advanced topics now. Aggregation and group by. So one of the things that people kind of get a little bit confused about when using DynamoDB is, how do you do a sum or a count or an average? How do you group? DynamoDB doesn't support that. So here's a very common example. If you're a SQL developer, you know exactly what this means, right? So select sum of amounts from accounts payable where department equals R&D group by employee. We do this sort of thing all the time. So what this is doing in a SQL database, let's just go through the process. So what it's doing is starting with the accounts payable table, which is the table that I'll show you the table actually coming up. I haven't shown it yet. We're going to go through the table. We're going to select where the department equals R&D. We're going to only keep those rows and we're going to throw out all the other rows. So we're filtering. Then we're going to look at the employee field and we're going to group the rows by that field. So we end up with multiple groups. And then within each group, we're going to sum up the amount field. Now you can imagine this if, for example, you're a finance department wants to go through and say for every employee, how much have we spent on them this year? It's kind of what this query is asking, right? Now, but without an aggregation, without the ability to sum or without the ability to group by, how the heck do you do this? Well, that's one of the problems with DynamoDB is it's possible to do this, but you have to have some advanced planning. You have to have the foresight to know that you want to do this particular query when you define your schema. So here's another way of thinking about this. What if I kept a record in my database of the running total of every user? And every time I submit an expense report, I add to that running total. Or if I go and delete from the expense report, I remove from that running total. That's an interesting way of thinking about it. So let's look at that. Let's look at the operations. But this requires pre-planning. So let's imagine in our database for each employee in the R&D team, we have a running total of money spent, initially set to $0. Okay. When a new put item operation is done to say, hey, Peter spent $50 on a cup of coffee. Okay, that's a problem. But let's say I spent $5 on a cup of coffee and I expensed it. What I'm going to do now is insert a row that says $5 for coffee for Peter. but I'm also going to go to my $0 here in my running total, and I'm going to change it to $5. And then the next one comes along, and then I'll change it to $10 or 15 or 20 or whatever. And I'm going to keep on adding to that total. And if I happen to delete an item, not that you should actually delete from your accounts payable, but let's imagine you could, then you're going to subtract the old value from the running total. So when you want to run that report, you don't have to do sum. You don't have to do group by. What you need to do now is you simply fetch the running total field that you already kept. Okay? This is pretty obvious. It's exactly the same as the previous query I showed you, except what we're doing now is we're doing that work as we go through all the changes. I'm not doing the work when I run the query. So what this says to you then is that DynamoDB requires planning. You need to plan ahead to understand how you're going to use it. And again, this is super, super fast and it will scale to millions of users, as long as you plan ahead to figure out how you're going to use it. You cannot just go in and arbitrarily type SQL queries and arbitrarily query what you want. It's not going to work that way. Okay, before I go to joins, are there any questions about what I just said? Let me check the chat. Okay, previous question, I guess, was which one is used more, Particle or the original version? Particle is very brand new, so I don't think it's going to be used that much. It's only been 6 months old, so probably the original version is used the most. Okay, are there any questions about this, how you form a query and how you pre-plan? I think that's a key point, key takeaway from today.
So finding total is sort of simple, but there can be a lot of complex queries for summing up and doing ranges. How do we handle all that?
For summing up what? Oh, you mean how do you handle the put item and the adding the number and stuff like that?
No, just keeping the total, it seems rather simple. What if we have to like do a total of some range, things like that?
If you total up some range, yeah, that gets a little bit harder. I don't have an immediate answer for that, but if you want to do really, really fancy stuff, you do it in memory or you don't do it at all. DynamoDB will allow you to do basic things like adding and subtracting to existing fields and things like that, but it won't let you do complicated things like ranges. Now, somebody can correct me if I'm wrong because I haven't looked that hard at it. I've just looked at these simple cases.
Thank you.
Okay, so question in the chat, is this sort of like pre-creating different views in SQL? Kind of. Yeah, I mean, it's kind of like a materialized view, I guess. I mean, a view typically in SQL is calculated at query time, unless it's a materialized view. But I think what we're doing here is we're saying, let's make small incremental changes to the data rather than pushing the complexity of the query to query time, which is what you do in SQL. Okay, in the interest of time, let me move on. Happy to hang around for discussion later on. So DynamoDB also does not have joins. And this is a bit mind-bending too, because if you're a SQL developer, you love joins. You use them all the time, of course. So how do you do it? How do you do it in DynamoDB? Well, if you think about SQL, when we do a join, we're actually denormalizing data. Because even back to your first class on databases, you would have learned about normalizing data. Normalize data, reduce the deduplicate the data, don't have data replicated. Use first normal form or cod normal form or whatever it's called. Figure that out. A join is when you undo all that and you make the denormalized table. You make a big table and then you start to filter out what rows you're interested in. Did anybody ever think about that? You are denormalizing every time you run a join operation, and that's pretty expensive. So again, that's why Dynamo is really fast, because you can't do joins. So how do you solve this problem? Well, there's 3 ways that I'll mention. The first one is kind of a clever one. If you have multiple tables, or even the same table, you just want to query it multiple times, you can actually run multiple queries in parallel. You can say, get this data from this table, this data from this table, and this data from this table, bring it all into memory, and then join it in memory, right? That's the way of joining things and getting the equivalent of a SQL join. Now, it doesn't have to be different tables. It could also be the same table. You could say, get me these things from this table and these other rows in the table and these other rows in this table and then join them in memory. And yes, it requires extra work. It requires that complexity of knowing how to join in memory and doing stuff with data structures and things that we generally try not to do because it just takes longer to do it and to debug it. But it does work, and it's really high performance, and it does solve the problem of how do you join. Option 2, don't use DynamoDB, right? Now, I think you've got the point now that DynamoDB really is about high performance if you can pre-plan your queries and structure your data in a way that you're going to very quickly access it. However, if you want arbitrary ability to SQL, join, and filter, and arbitrary queries, ad hoc queries, no, don't bother. Don't waste your time. That's not what you want here. You want scalability and performance because you already know how to structure your data in a good way. Plan B, don't use DynamoDB. Third option is kind of interesting. Single table design is something I learned about just a couple of years ago now. I think it's a fairly new concept. Basically, rather than having multiple tables that you join, just put them all in one table. Now, I could easily spend an hour talking about this. And when I presented this at Galvanize, I think I did spend an hour talking about it. But I just want to really quickly go over this technology of how you could store multiple tables in one table, single table design. So here's the accounts payable table that I mentioned. I have 5 columns. The first one is just called PK. That's the name of it. Now, remember in my first example, I called it org ID. I'm not calling it that anymore. I'm calling it PK, partition key. Second one, SK, and it's a string. Okay, that's all I'm calling it. The 3 others on the right, so the date, the amount, and the running total, these are just regular columns. I won't really talk about those much at all. What I want to do is focus on the first 2, the partition key and the sort key called PK and SK. This was mind-bending. It took me a long time to understand how this really works. The key thing about single table design is that rather than specifying the type of the data in the column header, you actually specify the type in the value itself. So the first one, the partition key, see I have DEPT hash. That says the value here represents a department. Okay, these are all departments, a department R&D, a department sales. I've embedded the type of the data into the data value itself. Now the sort key is more interesting here. The sort key, I've got 3 different examples. I've got employee hash, and then I've got total hash, and then I've got trans hash. So what this is saying is, okay, this is an employee record for Bob. This is employee record for Jane. This is employee record for Mary. Employee record is like name and address and phone number and stuff like that. This one, these next 3 are the running total. So this is the running total for Mary and the running total for Jane and the running total for Bob. Okay, and here's this field on the right-hand side here showing that I have the running total and this is what the total is. And that we just talked about that previous example. Notice that in this record here, this is the only field that actually has a value, right? Date and amount, those values are null. They don't have anything there, so don't worry about those. All the other records in this table are transactions. So transaction for Mary on May 10th, transaction for Jane on May 11th, and so on. So every time you add a new transaction, you just add a new row that has trans hash, username hash, and the date in it. And like, okay, mind bending. What are we doing here? So let's think about how we're going to query this. Now, if I want to find out about Jane's employee information, well, I set my partition key to department R&D and my sort key to employee hash Jane, and I'll get this one row. Okay, great. What if I want the total, running total of all of Jane's expenses? Well, it's this row. So I search for total hash Jane, and I get this row. Oops. And if I want transaction Jane on a certain date, I search for this row. But what about if I want all the transactions done by Mary? Well, in that case, I say partition key is sales. Sort key begins with trans hash Mary hash. So there's this row, and then there's the row 2 down, right? So I'm going to get 2 rows returned to me in that particular case, because I use what's the begins with operation, which is basically saying here's the range of values in this partition I want, is everything that begins with trans hash Mary hash. So I get all of Mary's responses. Okay, this still doesn't seem that powerful because all I've done is squeeze it in a single table, and why not just use multiple tables? Well, here's something that I can do that's kind of clever. What if I wanted to return all the data about Mary? What if I wanted to return the third row, which is her employee information, her name, address, and phone number, and so on? What if I wanted to return her total? And what if I wanted to return all her transactions? So it's this one and the 1, 2 down. How do I do that? Well, here's a sneaky thing. What I would need to do is create another field, which I haven't got on this table, but I could create another field called name. And then I can create a secondary index based on that name. And then I say, give me everything about Mary in that secondary index. And I would get all of those rows that mention Mary in the name. Okay, so now you're probably starting to see why I spent a whole hour on it when I gave this presentation previously. It's very mind-bending to think about, how do I store this data in such a way? How do I use these extra fields? How do I use global secondary indexes in order to structure the data in various different ways in order to get the data I want? Single table design, extremely powerful, but also extremely complicated to try and figure out the queries. But once you do, once it becomes, very natural to do that, adding extra fields, adding indices and so on, indexes and so on, becomes much, much easier to figure out. Okay, I'm going to stop there. Any questions about what I just talked about? The chat is empty. Wow. Either an amazing job or it's clear as mud.
I have a question.
Yeah.
So I know this is like a somewhat contrived example to keep things simple for us.
Yeah.
But you're not going to use values that are going to potentially change, like Bob, Jane, Mary. There's going to be more than one Bob. There's going to be more than one Mary. What if, are you in the real world? Would you be like pushing together some sort of like unique ID that is like abstracted away from the actual user data in this case?
Probably, yeah. I mean, and the stuff we did at Galvanize, we used a unique UID number. It wasn't really their email address. It's a unique UID, 20 digits long, that sort of thing. And you just use that everywhere. So yeah, you use that consistently. And what you need to do then is you need to do a different mapping, a different lookup from email address to the UID, and then you can start to do all the other operations consistently. Answer the question?
Yep.
We're all aghast. Thank you, Mark. That's true. Seriously, it took me a long time to understand all of this. I do encourage you to read a book if you're interested. I think it's called the DynamoDB book, I think. It's an awesome book. It goes through exactly how this works, and it goes through a bunch of different scenarios on how you query and how you structure the data and how you do one-to-one and one-to-many and many-to-many relationships and all of those things you're very familiar with in the SQL world. But that's a winded way of saying that's how you can potentially do a join in DynamoDB. Okay. Now let me finish up with transactions. I'm watching the time here. We're moving on. So transactions do exist in DynamoDB, but they're not quite as powerful as what you might think in SQL. Okay. In a SQL database, you're probably used to start transaction, do a whole bunch of stuff, lookups, inserts, updates, whatever, and then commit or roll back. And it'll either completely happen or it completely not happen. And you expect ACID compliance all the time, right? So other users of the database will look at the data that you're changing. They will not see your changes, right? Until you've hit commit. That's a super, super important thing to remember. So DynamoDB is kind of limited in that respect. It does support transactions, but it's limited to 25 actions only, right? So an action is reading a field, updating a field, inserting a field, deleting a field. Those are the actions. You can do 25 of those, and you can't have 2 actions on the same row of data. Oh no. So now it gets even more confusing. You're like, well, I felt really, really limited in what I can do here. Okay, I'll get to the questions. Yeah, thanks, Yuri. DynamoDB book, Yuri posted the URL there. So how do you do this in DynamoDB? Now, I want to go back to the example of the accounts payable. What if we wanted to add 100 accounts payable entries in one transaction? Now, this is what we normally do. And I know people who love SQL or love relational databases want to do all 100 in one transaction. And if one of them fails, they all back out. And I would say, well, why? Why would you do that? Why do you care? Is it really a problem if a different user looks at the database halfway through adding those 100 and they see 50 of them? No, of course not. It's not a problem at all. It's just that being SQL developers, we think it's the only way to do it, but it's not actually. You can add 100 of them independently, and that should be fine. So what you really want is each one of those 100 to be added as a transaction node. Because remember, our algorithm, what we're going to follow is that we're going to do a put item to actually write the transaction as a new row. Then we're going to go back and update the running total to sum up the value, okay? Or subtract it if it's removing from the table. So we do need those things to be done atomically. So here's what we actually do need to have done in a transaction. For each individual account payable, we need to check that the employee exists in a database. If the employee doesn't exist, you reject the transaction. Forget it, throw it away. Okay, if they do exist, then you're going to store the new transaction record by adding a new row. That's good. And then you're going to update the running total for that employee. This sequence of 3 things must be done atomically. It is not acceptable for somebody to come and see that the running total is wrong, or that it's only half updated, or the typical bank account problem where one person's adding, another person's adding it, but then you don't get the total of both of them, you just get one of them. You cannot afford that. So these 3 things have to happen in transaction. But that's okay, because we're allowed 25 actions. Not a problem. That's great. So the difference, though, is you're adding 100 transactions. So why not do each one of those transactions atomically itself, but all 100 of them are done using eventual consistency? So one example of how you do this: put them all into an SQS queue, pull them out one by one, do each one independently. SQS will guarantee that they get delivered to you, and off they go. They all get done eventually. It may take many seconds to get done, but each one will be atomic. Overall, they will not be atomic, but they'll eventually get there. So it does require a bit of a challenge. And I know that at Galvanize, when we're doing this, we had a lot of discussions about how to take the mindset that we typically had of big, long transactions and then break it down into small combinations of a small number of changes per item, and then use a queue or something else like that to make all of them eventually happen. Okay, any questions about that? Yes, let's have a look. Okay. I guess we're jumping back. Let me read Ding's question. And change query, really have the model well defined. Yeah, so a comment about, yes, if you've got to plan ahead. That's basically what we're saying here. You've got to plan ahead to exactly how you're going to structure your data, exactly how you're going to modify it, and so on. It's not an easy situation if you want to go and change your schema later on, because it's not just like SQL. You start to just write new SQL queries and you add a new index and it's really quick and everything's wonderful. It doesn't quite work that way. Okay.
A question here.
Yeah.
So you mentioned that there could be copies or a bunch of servers or replicas. So for these 25 actions, I would assume the put operations go to the main replica.
Yeah.
What about the get? Does it have to also go to the main replica, or is it okay if it goes to other replicas?
That's a good question. So the put will always go to the base table. The get can either go to the base table or it can go to a secondary index.
I see.
I think within a transaction, it's an interesting question. I don't know the answer within a transaction. Pretty sure you must be able to go to an index though.
Yeah. So let's say like we're putting an item and immediately getting that item. So would the load balancing direct the second request, which is the get request, to a different replica before it gets the copy from the main replica? So basically, yeah.
So that's a good question. I'm going to refer you to the DynamoDB documentation, which is like 1,000 pages, and because it does talk about this. And there's a thing called strong consistency and weak consistency, I think it is. If you're prepared to wait a little bit longer in your queries, you can guarantee you're going to have a consistent view of the data. Because the secondary indexes, it does take a little bit of time for the changes to get to them. And if you're prepared to wait a little bit longer, and I think pay a little bit more because it does cost, then you will be able to guarantee that it's consistent. But I'm not really an expert on that. So if you end up doing that, please check the documentation. They'll really help you. Okay, another question. Is talking about allocation of AWS Lambda server instance resources to dynamically adjust performance and load balancing for scalability outside? Yes. I mean, we can talk about that, but I think it is because AWS Lambda and load balancing really is not part of DynamoDB. At least you're not aware of it. We can certainly talk about it. There's enough AWS experts on the call tonight. I'm sure if you wanted to ask some questions about that. But yeah, DynamoDB, it handles all of that for you. You don't even think about it. Okay, next question. Is there any benefit in layering something like Redis on top of this? Or has AWS essentially already done that in the back end with the service? So good question. DynamoDB is fast, but it's still milliseconds because it has to go to disk and look on disk. Now, there is a thing that you can put in front of it. It's called DAX, D-A-X, DynamoDB Accelerator. It's in memory. So it's just like Redis, but it's 100%, it's not Redis, it's something like Redis, but it's compatible with the API of DynamoDB, and it sits in front of it so that if you do a query, if it's not in the DAX cache, it will go to DynamoDB, but then cache it. So you do the same query again, you'll get the much faster result. It will be done within microseconds rather than milliseconds. You could put Redis in front if you want to, but then you have to do that yourself. DynamoDB provides DAX, and it's really, really efficient. Okay, key takeaways. So my second to last slide, DynamoDB is scalable and high performance because data is structured efficiently. And I think that's the key message that I've repeated over and over again tonight, is that you have to think in advance about how you're going to access the data. Make sure you store it in that way. Make sure you structure your queries appropriately. And if you want to read about single table design, which is it's really fascinating topic for another time, you will get great efficiencies. It is not SQL, right? Full SQL is not supported because SQL will do joins. SQL does aggregations, and all of these things take a very long time to do. Lots of data, lots of processing, lots of in-memory stuff, and you lose all the efficiencies of DynamoDB. So full SQL is not supported, even though you can actually have something particle, which looks a bit like SQL. It's not really, just kind of, it's familiar syntax. Like I said, bazillion times, you've got to understand your access patterns up front and structure data accordingly. So that's the key takeaway. I love DynamoDB. I will use it as much as I possibly can in the future. I think it's a great, really easy to use, very efficient tool. But I do understand its limitations, but I do appreciate the speed. So I will jump into questions. If you open up the floor for any questions that you may have.
So question over here. So
yep.
Yeah, you said quite a few times, like even just 30 seconds ago, like if you can do your analysis and plan ahead and figure out kind of like the data model that you need to satisfy your business requirements or whatever, great. Is the corollary of that kind of like saying, if you see that things are going to like migrate over time or change over time, then this probably isn't the tool for you?
You can change over time. It's just not quite as easy as you might think in SQL, right? There's no reason why you can't add another index. There's no reason why you can't add other fields. You can certainly restructure your data if you want to, but it's not, I think the key point here is that you cannot just come along and arbitrarily type queries and expect them to be efficient. That's where your limitation is. But if you're prepared to go and add these indexes and add extra fields and so on, you can get there, but it's going to be very different to what you're used to.
And kind of on board with that is like, is there like some sort of effective schema document that like you could go and look, like if I have a relation table, I can describe it and say, oh, it's got these columns with these indexes on it, with these foreign keys, blah, blah, blah. Is there something like that that exists for DynamoDB, well, like when I'm using it?
Yeah, so there is a tool called NoSQL Workbench, I think. It's another Amazon product, and allows you to go in and basically say, I want my table to look like this, and I want my partition key and sort key and my other attributes. And allows you to basically model your data using this tool. And then, of course, you can go and actually generate the client programs as well. Like the code that I showed you, you can auto-generate that as well. So that's
Or
a great
what about
point.
the other direction? Like, say, I'm coming onto a project that may already use DynamoDB.
Okay.
Is there like a schema mapping that says like, here's the way things look right now?
I'm not aware of that. I mean, you can certainly go to the Amazon console and run queries through the graphical user interface, and that's really useful. That would be a great way of discovering the data. But unless you had some written documentation some way, I don't know how you'd figure out the structure of the data other than just staring at it, trying to figure out the relationships. Yeah, that's the same with SQL though, right? You end up doing select star, from a table and figure out what the data looks like and figure out what the joins might be and so on. Same principle. But yeah, totally think about NoSQL Workbench. It's a really great tool. Actually, the single table design was from that. That was exactly how I built that example using NoSQL Workbench. Okay, any more questions? Okay. Are there any support library tools to make it easy to concatenate, parse single table keys? Yeah, it's a good question. So single table design, you've got all these values with hashes in between them. One recommended way is to not actually try and read those. For example, if you had trans, hash Mary, hash date, actually have Mary and date as separate fields. So you don't have to parse them out of that key. That key is really just for lookups and searches, right? But if you actually want the values, use the fields themselves. Again, data's cheap, right? Storage is cheap, so why the heck not? Okay, well, I think that's it. I'm happy to hang around for a while longer if anybody has any questions about DynamoDB or AWS in general. Thank you very much for your time. Appreciate it.
Thank you, Peter, for your presentation. I also love DynamoDB, and I very love your presentation today because you covered like from the basic to very advanced topic as single table design. Like, thanks a lot. Thanks everyone for joining this presentation today. Next time we are going to meet on October 14th, and Mike is going to do some presentation. Mike, would you share?
Yeah, sure, I can share. Yeah. On October 14th, like the next meetup, we're gonna discuss a little bit different aspect of serverless related to the orchestration of the Lambda function and like execution of the complex, like complicated workflows using Lambdas and step functions. So please join us in the discussion.
Step functions are amazing, and it's very advanced technologies for serverless. Actually, right now, this pattern is covered only by AWS. It's like pretty interesting. I'm pretty sure like other clouds will start working with some similar technologies in the future. It's amazing. Like, we are looking forward, Mike, for your presentation. Good luck, and thank you everyone for joining. Have a good long weekend ahead. Like, see you next time.
Yeah, thank you very much.
Thank you.